So I think I'll just give a quick intro about you to the audience, just in case they don't know, and then you can get started with the presentation. Is that fine?
Sure, we can, as you told.
Yeah. So today we have Subodh Gajare from Cisco R&D Bangalore. Subodh is responsible for innovating across architectures and delivering solutions to meet customer outcomes. He designs SP IoT Enterprise, DC, and security solutions with laser focus on automation and simplification. He is passionate about creating intellectual capital that can be scaled and leveraged across teams and externally for customers or partners. He has implemented secure solutions spanning diverse architectures for clients like ATT, T-Mobile, Verizon, Rakuten, Jio, Vodafone Idea, and then the list goes on. He just keep talking and just continue on. He's passionate on creating intellectual capital that can be scaled and leveraged across internal team inside Cisco and externally for customers. So I'll hand it over to Subodh to start this talk. Yeah, thank you.
Sure. Thank you, Vikas, for hosting me here today, and Prajakta and Professor Rajput as well, whom we have in touch. If you're around on the bridge, do I have the sharing rights? Can I quickly start sharing my presentation, and maybe one of you can confirm?
Sure. Yeah, you can start.
Yeah. Hi, Subodh.
Hello, Professor. How are you doing?
This is really so nice to have met you, at least at this point of time. In fact, our MOU with Cisco has also been finalized. In fact, the primary draft which you had created regarding creating a center of excellence for intelligent networks and applications in focusing the 5G domain. So this will be amazing that we will go on for associating for research as well as product development and bridging the difference between academia and industry. So we are very thankful that now we have you on board continuously. In fact, our head of the department, Professor V.N. Mishra, he was about to join. In fact, I messaged him that he can join now, but actually he is traveling to Bangalore today. So he is on the way. So let's see if he joins. He might sometimes interrupt your session for a while, but in this meantime, we will carry on. Okay. So you can just start the talk. We formally welcome you to the valedictory session of UDYAM'22. And okay, you can start. Thank you.
Sure. Thank you so much for that. And yeah, I would love to. Rahul was kind enough, and he said, "So you got to do this for BHP." And I know Suhas has been a loyal. I believe so. It's been for the last 6 or 8 odd years, right? And we always hear from Suhas the passion he brings for BHP as an alma mater. So yeah, absolutely. And we will continue our interlocks and hopefully get to meet in person as well.
Right. Thank you so much. Welcome.
Okay, so Vikas, when I just say share, right, it showed me this. Normally Teams doesn't do that. I have the Teams back. Have you enabled the rights? I don't see a place where I can pick up.
I can see your screen.
Okay. Can you see my share now? The slide now? Let me know. The 5G sharing massive IoT.
Okay, voice is breaking slightly, or is it at my end? I'm not sure. Your screen, I can see your screen, but it's frozen in place.
Okay. All right. Let me try again.
Yeah, I can see your slides. Yeah, I can see your slides now.
Okay. Yeah, I think it does take some time, but yeah. So again, you can see the title slide now, right?
Yes. Yeah.
It does take a time.
Yeah, it's working now. I can see it now. Yeah.
All right. Splendid. So, hey, good afternoon, everyone. I believe most of you would be in the same time zone as me, which is in India. So a very good afternoon. If you're like me, if you've not had your tea or coffee or whatever beverage you prefer, I just keep sipping, nimbu pani or lemon water or ginger water, whatever you like, right? But something to just keep your minds and brain cells active. Because today we're going to really talk about 5G. And if you can see on the title slide, I said this is kind of not just a networking or a wireless / mobility technology, not just inside Cisco R&D, but I think everywhere around. We look at this, the whole industry look at this as the bedrock for the future of connectivity, the future of experiences. And it's very rightly said that both of them were there before in various avatars. So IoT was there for the last, I would say, 3 odd decades. 5G existed as LTE and 4G and a little bit of it in 3G. But now that they are all together, I thought the time is right, one, so that all of you get a sense of why is it just not about mobility and wireless. In fact, it is not. If you're thinking, oh, this technology now gives me a better phone and better connectivity, that would be just probably less than 0.0005% of it. There are various big constructs how each and every industry is going to innovate itself. Basically, it's all about understanding the technology, absorbing the most important things for it, and then going on this journey called digitization. So in a true way, 5G and IoT together with obviously enterprise blockchain, security around it, software-defined networking, and of course, the most important thing which we all consume, and that is apps, okay, applications. That will just bring in a new era. And I think Udyam has been doing this tech fest, as I think Professor Rajput was also sharing. This is the right time. It doesn't matter whether you are from mechanical, civil, structural, electrical. I would even say highway engineering, because some of the best greenfield expressways now rely on very deterministic 5G wireless and IoT technologies. So it's not just about IT and CS folks or telecom folks anymore. So that's our landscape for today as we start climbing up. And I jokingly call this like it's like a little half an hour, 40-minute climb. But hopefully, we don't sweat so much that we put ourselves to sleep, one, hence the tea coffee, which you now understood. And I believe the best way to learn is to ask questions. There's no other way I can think of. So there's no dumb question for the next 1 hour. If you have a question, anything in the realm of all of these technologies, just shoot and ask, right? We're talking about industry trends. So we are really talking about works of 5 years, 6 years, 10 years, maybe even 20 years back. And we are going to talk about AI ML, so artificial intelligence / deep learning, machine learning frameworks, IoT and the whole evolution, how it happened as overlays, and also look at details of 5G architecture too. Okay, I have certain assumptions, and I normally make this when I talk to college students. Right, you don't have to be an expert, obviously, in all, but there's maybe a little bit 1%, 2% which you may have heard about this. For example, you could have heard about cloud, right? So whether it's platform, infrastructure, software, data center, anything as a service. Mobility, obviously, I doubt if there's anyone on the bridge who does not own a cell phone. When I say own, I mean who does not have a 10-digit number to enumerate. And that's probably one of the biggest public routable network, right? Anybody in the world can reach out to you because the need to talk gets routed. So let's look at this really, right? And I thought one of the best way for me to engage with you, right? I'm not there in person. This would have been really nice if we were all in your beautiful campus. And I do want to make it to your city once. I've just been once when I was a child. So I want to see the new Banaras, the mystique of Banaras. But imagine if we were all at the famous some chart. I know there are some chart wallas who are absolutely famous, but let's say we are just in campus having tea, coffee, just having a candid conversation. Then these are my 3 R's for you. Engage actively, right? These are industry trends. This is not X equal to Y. This is X equal to sigma of every variable from A to Z. So there are probably a dozen different ways to solve and look at the solutions. Second is query boldly. This session could be the inspiration for you to ideate and disseminate your idea there. And I don't need to tell you, this could be even probably one of the seeding sessions, as we call it, for you to have your startup or even get that job. So I don't need to enumerate more. I think the purpose is dual. Let's have a very open conversation. And as I told you, there is no dumb question. I think the only dumb question would be the one which you don't ask and I don't hear. So let's make every effort. We have Prajakta, Vikhyat, and Professor Rajput who are eager to hear from you as well. So make sure you voice your questions. I have kept the last 10 minutes as strict Q&A. So I'll make every effort to wind up in the next 40 odd minutes or 45 minutes. But If there's any slide where you have a question, just hit your, just use raise the hand or something, or whatever you can think of. I think Project and Vikhyat, between them, they would be monitoring the chat. So either raise your hand or just put something in the chat. And hey, Project and Vikhyat, interrupt me at any time, right? Having said that, I'll take a pause after every maybe 15 minutes just to see if there's any questions too. Okay.
Yeah. Hello, Subodh.
Yeah.
Probably Professor Mishra has joined. So
Okay.
our head of the department. So let me just see. Prajakta, can you just ping Professor Mishra if he has joined? Namaskar, sir. Welcome, welcome.
Namaskar, namaskar. Let me wish you all the best for this wonderful occasion that we have at least been connected to what I must say world best networking, and in that networking I have been dragged and pulled over to Bangalore in I think a couple of hours. I'll be starting my journey. So I wish you all the best because ours is an academic institution and connectivity with Cisco team. And I think most of our students are also there. So it is their responsibility to update our capability and capacity in terms of field work. And I think this is going to be a wonderful start for our department. Thank you very much. I'll be traveling now. Okay, so you can just carry on, please.
Okay, okay. Thank you very much, sir. Thank you so much.
Thank you, dear sir. And we welcome you to Bangalore. I think if me and Suhas are in campus, we'd love to welcome you. But I'm in Pune myself for a deployment. But next time you're there,
I'm
let's
traveling for a very. I'll be reaching in the night and morning again. I'll have to return back. Anyway,
okay.
Next time I'll be with you also.
Yeah, safe travels, dear sir. And yeah, I fully agree with what you said. Let's be in touch.
Thank you so much. Okay, so what, now you can please continue. Yeah, please.
I'll resume. Sure. So, having set the context, having set the rules of the game, let's start playing the game, right? The game is all about, I thought the best way is, this is a survey taken approximately of 5,000 students per country. So around 120 countries, so maybe 500,000, so roughly 5 lakh students across the globe. But simply given this survey, and you can see the age group also, right? So pretty much this survey spanned from 10th standard onwards all the way to people pursuing their masters across various streams. And the question simply was, I cannot imagine a life without, and there were some options. So I cannot imagine a life without. 43% of your students felt my current partner. Okay, so no points for guessing, right? What that means. So that's pretty obvious. 64% of you felt I cannot imagine a life without my car. Okay, whatever that. So we have friendship, we have obviously urban mobility, if I would say so, or just transportation. But hold on, 84% of you felt I cannot imagine my life without the internet. And that says something, right? It says that it doesn't just, it's not just about that internet is more important, but it's the relevance for a student to learn, grow, and shape their careers, or shape their research, or build their project labs, or build a startup, or join a campus or a corporate company. So I thought this perfectly logical, right? The survey is almost 3 years old, just before COVID, and I thought this was perfectly logical, my friends, till I saw the fourth option. And the fourth option was almost 99% of you felt you cannot imagine your life without a mobile phone. So this tells me the mobile broadband or the mobile internet is now just like the heart and the mind and the body and the soul just going together. So the mobile is no longer just a communication device. It's going to consume the world. There have been like 5 or 6 evolutions of the instruments. Don't bother too much about the things on the left. I've hardly seen the first 3 ones, but in India, as look about, I think from 3.5G or 3G onward, when we started moving from the SMS to the packet world, and now we are in the, I would say, advanced LTE phase. And just on the cusp of 5G. So another 6 weeks from now, TRAI will start auctioning 5G for India. So what does this all mean? Then that's why it's very important we understand how do we look at 5G, right? And as I told you, if you remember this word called digitization. So let's take a pause here. Let's really look at this slide because this slide forms the context in which everything revolves around. So not going into the 90s, I think that's when you probably, some of you are even just born or just left your schools. But I would say when you say digitization, it's really about every process for a company, even a business organization like a roadside cafe, like a Starbucks, like a shopping mall, like an airport, like a campus, and an IIT BHU campus would be a connected campus, right? Now that connected campus is not just about Wi-Fi 6 being there or Wi-Fi 5. It's about all the processes also working on it. So you could be having your student library catalog systems. You could be having something else on it. So 4G took the mobile broadband and gave it more speed. So from 1 Mbps, we suddenly started getting 10 or 20. So if that was by a factor of, let's say, 15, 15 is a good average around the country. We should stable now get at least 1.5 Mbps. If you get 3 times of that, around 45, 50, you're pretty much getting the max given by India for 5G. So for 4G, sorry. So while 4G was tested, I think 4 years ago for 100 Mbps in the max, what really got rolled out at the theoretical level was around 45 to 50 Mbps. So if you're getting in an urban place, maybe like Varanasi campus, if you're getting 50 Mbps, consider this coverage spot. Now 5G, again, is the same logic. So one nice way to imagine 5G is think of 3 ones. Okay, the first one obviously is the 1 gigabit, right? The speed part, and that is obvious. So let's not talk more about it. But theoretically, it promises you 1 gigabit on your phones. That's the theoretical limit in the labs. If you get half of that, quarter of that, still times or times faster than the fastest 4G now. So we really say it's like at least 15 to 20 times faster. So 500 or 400 Mbps on your phone is something which we can start expecting by this year, and hopefully when Jio, Voda, Idea, and Bharti Airtel have start rolling the networks. Oh, by the way, since we're talking about India, these 3 operators have already rolled out, by meaning the testing is done, the end-to-end configuration, the rack stack, the fiber, everything is done, the allocation is done. All they're now waiting is the highways, the air highways in which frequencies get allocated. So in short, it means which highway should I use? I am bidding for 5G. I would like to have at least 200 million people. So I would need that much frequency and spectrum. So that's what they're waiting for. But coming back to this side, digitization is all about everything about a company now being online. And that's a huge, huge move. It involves people, it involves processes, it involves data, it involves endpoints, applications, things, you name it. I think the best way to imagine is it's really like, think about Uber, right? Or think about Amazon. How many of you have actually walked into an Uber say a store called Uber, or called an Uber and said you want a Uber, right? The service gets delivered to you use 3 technologies, right? So you have obviously your mobility, which is your phone, then you have the app, and then you have the internet. And then there's a lot of end predictive analytics which gets delivered, right? So in the same way now, 5G is going to go into each and every space of every industry. So the mines, even the discoms, the gencos, so distribution companies, the generating companies for utilities, electricity, gas, water, everything is going to be digitized. It is being digitized actually as we speak in our country. Transportation, retail, mining, as I told you. Transportation is both railroads, okay? So not just the passenger, but even the freight corridors being built, the signaling systems, the intelligent transportation systems or the interconnecting highways, then the airports and the air traffic controllers, you name it. Every industry is getting digitized. So it's a great place to be, right? And why would you look at that, right? So the first thing which is changing is the next generation radio. So this is where the electrical guys or your hats will start getting. If you wear your electrical hat, and if you remember the basic law of physics, right, which says what is the relation between frequency and wavelength. As you go higher in the frequency, your wavelength reduces. So if you apply that logic to 4G, 4G had frequencies from 700 megahertz to 1.2 gigahertz, right? So 1200. So it could travel up to 4.5 to 6 kilometers max, right? From anything up to say 5 kilometers was generally assumed. Now, when you go higher in the frequency, so you go beyond 2 gigahertz, and you can go all the way up to 64. Theoretically, most countries are exploring up to 24. Okay, so in short, if you go higher on the frequency, what happens to the distance or the wavelength? You can only go shorter distances. So you need a next evolution in radio technology by itself. So the first place where the most innovation has happened is the radio space, or we call that as the RAP, or the radio access technology, that, or you can even say RAN, radio access networking or network. So does this mean my 5G signals can only go half a kilometer? Yes, but hold on. I told you, right? Technology solves technology's limitations. So now there is a technology called massive MIMO, right? Multiple inputs. So while 4G had 2x2 antennas, you can even touch 64 transmit, 64 receive in 5G. Huge. Okay. And then there is beamforming, which exactly repositions the radio signal so that it scatters the maximum. So it takes care of the usual distance limit of 4G. And you can also provision a lot of this in software. So millimeter wave, small cells, massive, multiple input, multiple output, beamforming. These are some of the disruptive technologies in the next generation radio. And hence 5G's radio access technology is also called 5NR or just NR, next generation radio, okay, or new radio. In 4G, we used to call it G node B, right? In 3G, it was E node B. So it's immense when you look at it, right? Just showing you this graph so you get a sense. Now, let's look at it from an IT world computation also, right? So I'm not sure if you folks have heard, so every 5 to 6 years, we look at S curves, right? So earlier there were centralized client server applications. So because they are like S, by S, I mean, they'll be flat for some time. If you're watching my hand on the x-axis, suddenly there is a hockey stick movement, which is they rise, and then there is again a flat, right? So we had client server, then we had distributed technology. So clouds came in. Then there was the area of multi-cloud. So now we all know the public clouds like Amazon, Azure, Google, Cisco, all of them are there. We are again back in this distributed intelligence world now. So apps distributed, data distributed. In fact, in 5G and IoT, we call it fog. Okay. In case you're wondering, hey, why fog? I'm sure you are, right? So I think it's all about clouds. The moment you say cloud and internet, people generally think. So in terms of networking, we have certain parameters like throughput, latency, right? So generally, the round trip delay for a VoIP call around the world would be around 120 to 100 milliseconds. In 5G, it is now brought down to almost 5 or 10 milliseconds. So cloud is simply a fog or a mini cloud is simply a cloud very near the endpoint. So you don't go around the world, you save on latency, you save on bandwidth, you have the best round trip response. So imagine if all the sensors in your Varanasi campus, they're generating data whenever students, for example, open windows, open doors, motion detectors, cameras, security cameras. If all of the data is being sent to a public cloud, which could be, let's say, Delhi, or anywhere in Punjab, or say Srinagar, or say down south here in Bangalore, there's still going to be, maybe I would say 200, 300 milliseconds of delay. How about having a local fog cloud, edge cloud, fog or edge computing, as we call it? And that's the premise. So wherever the data is generated, have a cloud which will have networking, which will have predictive analytics, which will have the best storage, the best silicon chips. And that's the whole premise. So that's why we call it distributed. Everywhere there is cloud. And a nice way to imagine is also like, I always imagine, right? Imagine if you only had one chai wala, just one chai wala. And that too, that person who he or she is 2 kilometers from your campus. And all you're doing is everyone needs tea, right? In India, it's all about, hey, innovation happens on tea, right? I don't need to tell you, or coffee, whatever you prefer. But if that same tea quality is now given every 50 meters, same thing is meant. And we all know, right? We just go and say, sometimes in Hindi, hello, bhaiya, dada, adrak wali bana do, zaike wali bana do, something like that, right? So the same treatment at the same price point and the same quality is delivered local nearer to you. You may not even have to walk. You sometimes just order from an app. Okay, and that's what, by the way, you do on Amazon Cloud, EC3, right, or S3, whatever. You just say 4 of us are starting a startup, which is like, say, Redbus, right? I'm just giving an example. You want to make sure all people in Banaras can utilize your startup. You actually leverage or borrow or rent Amazon Cloud services, and you just say you want this. And then on that, you can even buy Cisco's networking and cloud services. So you're just renting it, and you're giving the same services, and then you're guaranteeing payment gateways, payment reconciliation, and so on. So think about it. If I had to list all of this down, I would say the building blocks of 5G, right, which is pretty much what I would like you all to leave with, are going to be 5. Quick summary, right? Just so you understand. So one is a radio. I told you, next generation radio. The last bullet is also important in the context of take Wi-Fi. We all use routers in our homes, right? In COVID, you folks would not have done your engineering if there was no Wi-Fi in your homes. But you don't pay for Wi-Fi. You pay for the SIM on your phones. All Wi-Fi routers in the world are configured for 2 frequencies, right? So there's 5 gigahertz if you have a dual band router, and there's 2.4 gigahertz. These frequencies are reserved. It's like the airport signs, right? We always have this black and green, black and yellow signs. And there's only one sign side, it says immigration officer, and we just go by signs, right? Just like that. Imagine this reserved frequencies are for Wi-Fi. So it's unlicensed radio. There is no license required. There is a license required for your mobile. When you subscribe to a Jio or an Airtel SIM, you buy the SIM, but you're also latching on to Jio and Airtel, which has licensed the airwaves. So cellular connectivity is licensed, Wi-Fi is unlicensed. Similarly, in IoT, right, you have narrowband IoT, and you have Wi-Fi, which is unlicensed. You have LoRa, LoRa stands for long range, in which frequencies below 1 gigahertz. So in India, it is 840 to 870 megahertz. And these are the frequencies which are used for your smart meters. By the way, I think Varanasi, some part of the Varanasi smart city uses LoRa as well. So you can have your electricity meters, whoever provides electricity to your campus, all of them calibrated on LoRa. So all it does is every time the meter in the coil finishes so many revolutions, at the end of the day, uses all of that data and just sends it over a TCP/IP packet to the nearest server, right? That's how connected utilities and cities look like, by the way. Okay, back to the 5G building blocks. The next is IP transport. So by now, if you have not heard of TCP/IP, this would be a great time to understand it, right? So TCP/IP is the addressing, routing, and the transmission protocol of the internet, public internet. Up to a decade ago, so up to 2012, TCP/IP version 4 was great. It serviced our needs. But then just because everything started coming on TCP/IP, a new protocol was invented, new version, you could say. So just like earlier, maybe the earlier Maruti 800s are good, but now we need to have this half-connected cars, right? So just like that, from TCP/IP version 4, the whole world has moved to TCP/IP version 6. I just wanted you to remember. The biggest advantage of 6 is it uses the same routing principles of 4, but allows you to scale better. So more addressing, almost we jokingly say, right? It's like billions and billions of IP addresses, and you don't need to remember all that. It's same principles, and you can easily switch from version 4 to version 6. Next time you get some chance, you want to tinker around on your phone, just go to the internal system details. You'll always find those MAC addresses, right? So if your phone is a dual stack, you'll always find a 48-bit MAC address. You'll also find a 128-bit. So IP version 6 addresses are 128-bit, right? So 2 to the power of 8. And IP version 4 addresses are 32 bits, right? 2 to the power of 5. So version 6, how will that be transported? So IP transport is all about somebody makes a 5G call that all the voice packets, video packets need to go within that 50, 60 milliseconds to the other side of the world, or sometimes even come back and complete the transmission, right? So all that slicing, timing, security happens there. You'll hear words like front haul, back haul. So front haul means from your phone or endpoint, user endpoint, to the cell site tower. That is front haul. From the cell site tower, the fiber begins. The fiber then converts the optical to the electronics, and then pulses of obviously electricity, and then the TCP/IP packets are framed, sequenced, and passed, and hence rightly so, it's called as backhaul. After the transport is the edge compute. We spoke on that as a fog earlier. In the 5G world, we just use a different term called MEC. It means the same. I told you whether you say fog or edge compute, but here it stands for multi-access edge compute. So you could come on a Wi-Fi connection, you could come on a cellular connection, you could come on Wi-Fi 6, the latest version. And then you use technologies like software-defined networking, in which you don't worry much about the routing principles, right? So in a way, you're breaking the connection between what is my next hop and how do I get there. So whole of public internet is now a software-defined network. And then you have open APIs. So when I say APIs, I mean application programmable interfaces. In short, this means whatever you build in such a way that anybody else can integrate with you, right? One of the best usable open APIs is Bluetooth, public domain, okay? If you say something has a Bluetooth connection, you can pair anyone with it. You just pair, exchange a local key, build a connection for low speed transfer. Even if it's 1/4 of a megabyte, you can connect and then stream music. The fourth pillar is the SDN fabric, which is the evolved packet core, or sometimes we also call it the virtualized packet core, okay? And the fifth is orchestration, and that is at the software layer. How do you piece all this together? One thing is building a network. Second thing is if you have 50 lakh users using this network, would they understand? How will their billing happen? How will you have open APIs and controllers to simplify the operations? You don't have to fill up forms. You all know in 4G, you could walk to a Reliance Jio or a Bharti Airtel store, and if you had your 12-digit Aadhaar, your KYC used to happen in less than an hour. Now imagine in 5G, you actually have a eSIM, electronic SIM. I doubt if somebody will actually walk to a store to get a 5G SIM. Okay, if you have the 5G phone, it could be provisioned through software. So there are a lot of innovations which can happen, right? So all of this orchestration is done by the software layer. All right, quick pause here. I think we're just on the half of the segment, 4:35 on my watch. Any questions, Vikyat, Prajakta? Anybody has any questions before we go ahead?
Nothing yet. I'll update you. I think we'll take it towards the end. Right? So I think we'll take it towards the end.
Okay.
Nothing as of
Okay.
now. Yeah.
Yeah. So far the flow looks good. I presume we can just go ahead, right?
Yeah, you can go ahead. Yes, it looks good.
All right. So this is how, so open compute, when I say open, I mean, there are a lot of open source technologies, a lot of players who are in this space, to name a few, apart from Cisco, right? So we have our own systems, obviously, software, hardware, the chips. We also make the same chips which run the world's biggest routers, right? I'm talking
It's not audible.
Hey, this is Subodh. Can you hear me, folks?
Yeah, we can hear you. Yeah.
Oh,
I think your
that's
net
why Rahul. Yeah,
between
Rahul,
and
I
then
saw
some
your
of our net is gone. So
right. I guess that. So, how long did you guys miss me? Was it on the last slide? Let me start on the IoT slide.
yeah, I think yeah, somewhere
Okay.
around there. Yeah.
Okay, we can let me know. This is pretty much, I think, 3 more slides and we should be done anyway. But I
I
think,
think there's been a problem from our end as well. The power in the whole of the campus is gone. So
oh, that figures.
we're joining.
So,
People are joining on mobile data as well. So right now, so yeah, we'll get the questions to you. Don't worry. Not a
okay,
problem.
okay.
You
Cool.
can continue the presentation. Yeah, because we're
Yeah,
recording the session anyways, right?
look, yeah, completing the presentation is really moot. It's secondary.
Yeah, exactly.
I'd rather have questions. So it's anyway 4:45. Rahul, thank you. I saw your missed call on my mobile and I guess something was wrong. Thanks for the heads up.
No, no problem, Subodh. Yeah.
Yeah, so I'll leave you with folks with this.
Actually, we also got a power failure at our campus in my colony also. So now I
Ah,
want mobile data. So actually, somewhere we essentially need a 5G connectivity, which is immune to failure as well.
yeah, absolutely. Absolutely. So I'll leave you folks with this, right? The digital disruptors are there, but it's not just about connecting, right? So for example, so this is an experiment we did in Jaipur. It's a Cisco solution, right? But I know this is heavy animation, so I really hope it comes out well. But this is a nice case study. It's happening in Kochi, Pune, New Bombay, started from Jaipur. We're even doing it in Vizag. So this looks like a traffic pole, but we call this like if you apply the right things. And I thought this will excite, especially the EC department, right, Professor Rajpur? So the function of a light pole is to emit light, is illuminate, right? And that's why we have a single sodium or a simple tungsten or a sodium tungsten filament, sodium vapor filament, which will give light. But the moment you bring the premise of IoT to it, if you're watching it closely, you can actually have a new generation of lights from Philips or Lumens or Johnson Controls. And these are digital LED lamps. And the fact, when I say digital LED lamps, they will have a little PCB, this much the size of a PCB, which is really a controller. It's a light controller. And it has a Bluetooth and a TCP IP gateway function. And now suddenly, white light can be programmed, which means each of the light PLCs can act as sensors and they can do a lot of spatial understanding. So, for example, two poles, um, say separated by 30 meters, can park 3 cars exactly by talking to each other. On this light poles, if you notice, we have put a 4G dipole. So we have put a little router function there. And if anyone is just within these two poles, he or she can get a free city Wi-Fi. And that's how you can have the first step of a citizen connected to a smart city. Obviously, if you're doing parking, you can also do metering. By metering, it means if you park, say, in the morning busy peak time, so morning 8 to 12, it's peak time. 12 to 3 is considered off time, and then again from 4 to 8 peak time, the parking charges are varied. So there's no hassle, no ticket collection. The meter, you park your car, and the app just takes care of the parking, and then we can integrate various functions in it. Uh, I think the point I was trying to make is for all of you with ideas, stop thinking about IoT just as a sensor connecting or emitting Bluetooth or TCP/IP packets and connecting. And as far as you make something move or detect, it's done. It's actually the value from the services, right? From what you do with that. If you go in that space, it becomes very easier. And last but not the least, uh, to also get value from data, think about this little, very easy to consume software. It's just like your net banking, right? All of you use SBI, ICICI, SDFC, Bank of Baroda, some bank app, imagine. So when you just click on your phone, right? I'll just say, let's say you click ICICI banking or SDFC banking. You're just running that much line of code required for you to log in. You don't realize, but you have a 4G or a Wi-Fi connection. This is assuming you are connected to the internet. And every time you just keep on pressing, you're just running that little lines of code. The app is distributed all across. You don't even know which servers in Varanasi or even outside Varanasi would be having that kind. So things require apps, and then you need those apps to derive the business value so that people don't have to visit a bank. And this whole things and apps are now distributed. For the first time in the history of mankind, the distributed app space now gives you the ability to run this everywhere. And that's why all of this are now connected. But all the startups in the space, when they say we are in the SaaS business, they're solving some of these problems. So I'll leave you with this for your research papers and ideas because we are exactly 10 minutes short of the wrap up time. This is what you have to solve, right? These are the places where you have to solve and think about things. So promise you my final slide, a nice way to imagine. So things and apps will always need to be connected. A thing could be anything. It could be a robotic arm, a roadside signal, a wing of an airplane, a turbine, an arc reactor. It could be anything in the mechanical, electrical world. It could even be just a shutter of a dam. A thing from which some action needs to be detected, analyzed, computed, and then somebody who operates or needs visibility on that thing which you monitored can derive some value. And that view is from the app. In between is where the magic happens. Okay. So as a startup, you look at a problem or you look at a thing or an event, and then you build an app and you take ownership of all of this. This is the simplest way I can explain. So everything what we do, what Cisco does, whether it's whether it's IoT, enterprise, blockchain, security, 5G, obviously, is in this space. Okay, I think we can park here and keep this slide, or we can go back. And if you have any questions, yeah.
I think there are a few questions. So
Yeah,
one
sure.
is, so with big companies pushing towards the metaverse, how important is 5G for actually realizing that dream?
What was the last word? How important is 5G?
Is 5G
Realizing.
for realizing that dream?
Oh,
Like
that
towards for the
dream.
metaverse?
Oh, yeah, absolutely. Absolutely. Oh, yeah. So if you're looking at just this industries, and if you imagine the internet in between, right, that cloud thing, metaverse in the industrial automation space. So you see that robotic arm right here, top right, and that meter.
Actually, we can't see your screen right now.
Okay. Let's
Not
just
sharing your screen.
skip it. Don't worry. I think it's just a data thing. I'll just come back. Don't worry. We'll just talk. So I think the concept of metaverse is what has appealed to everyone. But think about the real application of metaverse is, hey, I presume you can hear me, right, Vikyat?
Yeah, you're audible and visible. Just your screen. You just can't see your screen.
Yeah, don't worry. There's nothing on the screen. I'm not sharing anything now.
Yeah. Okay.
So give this example that metaverse, yeah, because it has evolved from Facebook or the next evolution for Facebook. But I think metaverse kind of technologies, if you disintegrate, three things stand out for you, right? So HR, hybrid reality, augmented reality, or you would just say virtual reality. Now, if you really think, one of the best industries which can use this is uh, in the manufacturing world, and there are many industries in the manufacturing world, but think about auto assembly plants. Think about places where turbine reactors, generators get assembled. Now, there, very precise instrumentation, PLCs, human machine interface operations are done. So, for example, Prajakta could be in one plant in Manesar, Vikhyat could be in one plant in Gurgaon, Subodh could be in one plant in Vizag, Rahul could be in one plant, let's say in Kochi. Okay, if all of us need to share the same thing, just like all of us are now sharing on Teams or WebEx, and if you're troubleshooting that precise noise vibration handling rivet number 33 on the front row seat for the next whatever, right, Mahindra or Suzuki car coming out. So we need a simulation plane, right? So I think the meta technology, metaverse technology, whatever you call it, for me is about simulation for the right industry. If I can project and not send a human being, if I have a semi-automated robo or a AMR, automated motorized robos, or a AGV, so automated guided vehicles, to go and troubleshoot in those very harsh domains, right? So think about Saurashtra, think about places where oil and natural gas, so GAIL, think about HP, Indian Oil, Bharat Petroleum, and their oil rigs. Uh, 50 meters up near the oil rig, you cannot send human beings. Or you can have helmets on which they will measure how high the person has gone. Now, you can have the application of meta there. And that is a real implication of automated reality. Yeah, everything else is fine. You can sell houses, you can do expert care, medical care, healthcare. For those of you who are interested and want to research further, look at how telemedicine is changing. You don't need to visit a nurse or a doctor. You can actually just show right, your body vitals, and on a safe, secure connection, they can actually investigate in a physiotherapy level why your arm or motor movement is not up to the mark. Innumerable examples. All I'm saying is, for the first time in the history of mankind, we never had a chance for having reliable, low latency communications at such blazing speeds. 5G does that, and that's why Meta also becomes a possibility. I hope that kind of answered your question, buddy.
Yeah, that actually makes a lot of sense. Yeah. So another question is like, since the number of devices will increase a lot and 5G will have to work with existing devices as well. So won't there be some security concerns which are established? Like new devices can have their own new security features, but connecting old devices to such vast networks, won't that have their own set of security problems?
Yeah, absolutely, absolutely. In fact, I would like to know the name of the person who asked this. Can you share his or her name? Do you know that?
This was asked by Pranav.
Pranav.
Pranav asked this question.
So Pranav, bang on the money, right? I would say the question of the day, if I may just, and it's just relevant. I'm not saying this is the only important question. Even the earlier question was equally important. But this question becomes relevant for two reasons. Every legacy device connected is forming an army. Even in your home, you may not realize, but you already have many endpoints, which may come on the IoT world in some time. Now, the way we install apps on our phone, either from whichever Play Store, and the way the sandboxing of memory, CPU, software is done by the phone is an orchestration by the OS of the phone. Okay. For devices like if you're putting sensors on your cars, dams, controllers, IoT and security were like oil and water. Nobody thought, hey, let's put a PLC, we'll worry about, we'll have 3 supervisors and they will have some yellow badge swiping cards. What happens when the card gets stolen? Right? What happens when somebody just steals your connected helmet and goes and does something? Intellectual capital gets compromised. So we all know, we have seen that in millions and millions of movies. I'm not going to talk about it. Let's talk basic, like engineers to engineers, Pranav. Onboarding of devices, that itself is the biggest challenge in 5G and IoT. How do you get these devices onboarded and then get them assigned to the network? Okay, so secure onboarding of every connected device is one, and then the identity and management. So for example, I have a bracelet which measures my health. Let's say, Pranav, you take that from me with or without my permission. Doesn't the application change? You could be using it for monitoring something else, maybe your lymphatic nodes, maybe your body vascular system. So role-based access control comes into play. Your identity and posture management comes into play. Most important, are you supposed to use that in the first place? Can I have a 3-step authentication? So one could be, I think this looks like I've authorized Pranav and maybe Prajakta to use it. So can they authenticate themselves by a fingerprint or a FaceTime or Aadhaar? So all that device authentication also comes into play. For all of this and much more, IoT has only prescribed standards, so has 5G. But natively, 5G security and IoT security is a great place even to build your startup, whether for healthcare, manufacturing, because all of the sensors, they don't have a lot of CPU, right? Just that little CPU to store an event. A robotic arm, 25 times per hour goes up and down. You want to trap that event, push it up on the nearest cloud, and then go further from there. So think about this. I think security is a big thing. And then obviously, you heard a lot about how people are hacking into each other's cars, not just data centers, but other things. I know this is happening every day, but all I'm trying to say is it's happening because the rate at which machine to machine connections are happening is double the rate of what mobile connections are happening. We think mobiles are growing the fastest. They're the second fastest. The first is machine to machine, M2M, right? So great point, Pranav. Yeah. I can take one more question. We are just on top of 5, but I can have one last question, Vikhyath, if you like.
I think another common question, which is quite simplistic, but is just, are we ready? Like, is India as a country ready for 5G? The rollout of 5G?
Yeah, it's a broad question. It's a nice question too. I would applaud that the person who asked it. In many ways, we are. In many ways, we were also, right? But again, I would say this: the operators being ready is one thing. The ecosystem players around, the security players is one thing. Second is the citizens will consume only that part of 5G, right? For example, students, citizens, all of us. For us, obviously, the biggest benefit is better connectivity on phones. The enterprises will consume 5G in a different way, and that's called private 5G. I'll just leave you with the thought. Go and Google and research. You all are empowered. So, private 5G, for example, for a campus like BHU, could be that you would have a cloud fabric which will promise at least 20 gigabit, right? And I'm not saying every student will get that, but maybe student will get, as far as you're within that umbrella, that software defined fabric of say 20 gigabit backbone, every student could get at least say half a gig in the Wi-Fi. When you come out and leave your rooms, hostel rooms, you're walking around in the campus, you just change your network from the Wi-Fi router in the room to the private 5G in your campus. When you come out of the campus, you did one more hop. You went from the private 5G of your campus to a public Vodafone or an Airtel 5G. When you change even Varanasi and come out to Delhi, you went from public network 1 to public network 2, which is roaming, and so on. But all of this changes, my friend, we are ready. And I'm very proud to say that we will not make the same mistakes with India, China, and Japan are making. Again, this is a very personal statement, but I believe the biggest advantage in not being an early mover, biggest advantage, I said, right? So you can watch the top 3 mistakes done by all of them. So China, Japan, US, a little bit of Europe has gone ahead. We have around 70 odd 5G deployments in the world. Cisco is part of all of them almost. But now we know the best practices. And when we embrace 5G, we suddenly leapfrog, right? Just like 4G, we came in maybe 6 years later than US, but the proliferation was immense. The Geo story between 2016 to 2018, and suddenly we touched, right? So I believe even if we turn on 5G pilots by end of this year, whatever number of time it takes is hardly a concern. I think everyone will embrace it. But the price point, the security, how will the next IPL matches look, right, in 5G connected stadiums? Now that will bring a lot of people back to the stadiums. Think about those use cases and how will everything work? How will all the industries be modified? Wonderful things. How will the campuses of the future work? I would love to see how BHU looks like with 5G. Yeah. All right. I'll leave you with that.
Yeah, thanks a lot. Sounds like a very interesting proposition. Need to think about it. Yeah. So thanks a lot. Thanks a lot for your talk.
Sure.
Final words from NSR Mutsu. Yeah.
Yeah, okay. Thank you very much, Subodh. We sincerely extend our best vote of thanks to your talk. The way you have made our students visualize how things are going to change. In fact, in the same context, the way you have envisioned the way 5G private network platform would feel like when we will implement the same at IIT BHU. So in fact, we are all looking forward to have our first hands-on experiences on 5G platform along with our scope of contribution for its customized further development in association with our industry as an industry as strong as Cisco is globally, supporting all the 70 different deployments all across the world. So let's look forward to have many more things to come. Thank you very much.
Absolutely.
Yeah. Yeah. Bye.
Sure, sure. And again, kudos to all of you for a very happy Udyam. And as I said, next time, probably Rahul and me, in person, along with Samta, Suhas, would all like to come down and spend a quiet evening there with your department,
Yeah.
Professor.
In fact, probably when we will do the MOU sign up with IIT BHU, which has almost finalized between Cisco and IIT BHU, maybe at that time we will organize an event where you people may flock in, do a 1 day or 2 day brainstorming of all the students and faculty members, and let us look forward to do a lot more than merely organizing an Udyam platform. Now we have a very good and stable association. So let's look forward to achieve much more beyond this.
Sure, sure. I would love to for one. I work very closely through NASCOM and IEEE. We can do focus sessions just for electrical, your department as well, because I
Correct,
think the
correct.
synergies are immense and I can share the best practices for some of the biggest electrical substations which we're doing, a couple of projects which we're doing for massive country transformations. I would love to, love to. Let's connect offline. Absolutely, Professor Rajput. Yeah.
Perfect. Perfect. Thank you so much. Huh? Bye.
All right. I'm signing off. Thank you. Thank you, Rahul. Thank you, Rahul. Yeah. Projector, thanks a lot. Really appreciate your help too. Yeah. Bye bye.
Thank you so much, sir, for joining.
Yeah. Cheers.